Okay, we're moving into algebra expressions. Okay, we're going to start talking about variables today. Now, on Thursday, we talked about what? What did we do on Thursday? Expressions. What kind of expressions? No. Those are, what is that part of, though? Okay, we used order of operations to solve what? They were numerical expressions, okay? So they were just all numbers. Now we're moving into algebraic expressions, which involve variables. Now, right here in the vocabulary startup, okay? Algebra is a language of symbols, including variables. So a variable is a letter, or is a symbol, usually a letter, that represents an unknown number, basically, okay? So we're going to start using this right here. This graphic organizer sets up how you do vocabulary. Okay, we're going to start using these on almost an everyday basis. I like this setup. Okay, so basically, right here in the middle, we have our vocab term, variable. All right, that's what we're going to be working with. So the math meaning. Does anybody know the definition of variable? Use your resources. Layla? It's a symbol. What else could you add to that? Usually a letter. There you go. It's the second sentence right up here, guys. So a variable is a symbol. Okay, usually a letter. Okay, used to represent a number. My handwriting's terrible with this. Okay, so it's a symbol, usually a letter, that represents a number. Guys, you should all be writing this down. We have a workbook for a reason. These are your notes.
What's the last word?
Represent a number. I know I got a little sloppy there. So right here, Duke it. It's that sentence right there. That's the definition of a variable. Okay, that's how we're going to be using it in math. Now, does anybody know the everyday meaning? So outside of math, what variable means? So think about it. If you broke variable down, what word is in variable? Does anybody have an idea? It's a 4-letter word. Layla? Able, yes. That would be part. I'm thinking more towards the front. Vary. What does vary mean? What does it mean to vary? You're on the right track. What does vary? When you hear vary, what does that usually associate with?
Berry.
No, not berry. Vary with a V. Well, I get that.
I think of berry.
Okay. Well, I'm talking about more of the definition, guys. Okay. What does vary mean in everyday? Not quite. No, not quite. It means to change. Okay. Something can change. It can vary. So, like, whenever you hear about something that varies a lot or there's a variable involved, you're usually talking about weather. Okay. The weather changes all the time. The weather can vary all the time. Okay. So, what I want to put here, okay, is able to change. Okay. Let's just put that. Is able to change. It can vary. Now, does anybody know what an example of a variable is? So look at the definition and then come up with an example for variable. As well. Okay, you almost put a little bit too much on it. Kind of get that a little bit smaller. What is going to be the variable? You're on the right track. Layla, can you help her? You're still close. You guys are adding too much. I just want an example of just a variable. F. Guys, just a letter. So it's a symbol, usually a letter, used to represent a number. So you can have F. How many other options do you have? The whole alphabet. So 25 more options. Now, before we move on, you guys start writing a bunch of letters. The most notorious variable that they use is X. Okay, you will also see Y is common as well. But X is the most notorious one. Okay, you'll see that a lot. Now, what would be a non-example of a variable? A number, any number. So 4, 77, 3 8/10. Okay, those are non-examples. Those are all numbers. Okay, variables are letters. All right, so once you have that, let's go down to the real world link. Real world. All right, so down here, now it says a box contains an unknown number of markers. There are 2 markers outside of the box. The total number of markers is represented by the bar diagram below. So here we go. All right, here's our bar diagram here. Now, they said 2 markers were left outside of the box. What would this represent? The unknown number of markers. What's that represent? Layla? The number of markers in the box. So I'm going to, above it, I'm going to write box. And then you can put like outside on this one. Just so we know that that means the box. That's talking about outside of it. All right, we can label that. So using this, number 1 says, suppose there are 14 markers in the box. Find the total number of markers, and then we have to explain your answer. So if there's 14 in the box, what is our total going to be?
16.
How'd you get that?
Because 14 plus 2 would be 16.
Exactly. You explained it right there. So it's 16 markers because you have to do what? What'd you say?
Add 14 plus 2.
You do the 14. Where'd you get the 14 at?
Because it says 14.
I know, but where are the 14 coming from?
I don't know.
Where are they at?
In the box.
In the box. There you go. So because we add the markers in the box with what? With the outside markers. And that's how you explain it. And then another thing you could throw in there would be 14 plus 2 equals 16. Okay, that's your explanation. It wasn't a long one. You didn't go into great depth. We literally just talked about how we added. That's an explanation, guys. It doesn't have to be a page. It doesn't have to be a long description. It just needs to explain what you're doing there. In this case, we added. All right, once you have that, go on to the next page. All right, so evaluating one-step expressions. So we have a one-step expression is basically just one operation. Does anybody know what the operations are? When I say operations, what am I talking about, Isabella? Huh? You're close. You had one in there. They're involved in equations. When I talk about operations, what are we talking about? That's part of the format, yeah. I don't even know what you said there, pal. Okay, so when I say operations, I'm talking about when we add, we subtract, we multiply, we divide. Those are the operations, okay? Addition, subtraction, multiplication, division, all right? That's what we're going to be working with. So there's only 4 of them. All right, we're doing addition, subtraction, multiplication, division. Now, when I say one-step expressions, we're just doing one each time. All right, so an algebraic expression contains at least one variable and at least one operation. Okay, so we're going to have a letter and we're going to have one operation. So this is an example of an algebraic equation or expression. Sorry. It's not an equation because we don't have an equal sign. So any letter can be used. But like I said, notorious one is X. The letter X is used majority of the time, so you're going to see this a lot. We talked about a little bit of this on Thursday with the multiplication. Okay, remember you can have a dot now. Emily, put that away, please. You can have a dot. That means multiplication. Parentheses mean multiplication. And then you just write it like this. That means multiplication as well. This is going to be a little tricky. We'll talk about that here in a little bit, why that might stump you guys a little bit. Okay, but you'll see something like this, n plus 2. Okay, can you solve that?
Yeah.
How?
I know.
Oh, how? How do you solve it?
I know.
Well, what's n?
4. 4. Oh, 4.
How did you guys just come up with 4?
Unknown number.
It's an unknown number, so we can't solve those. Okay, unless they tell you what it is. That is as far as you can go. That's simplified as far as you can go. Okay, because we don't know what n is. Now, when they say evaluate, they want you to evaluate the expression. All they're wanting you to do is find the value of or solve it. Okay, that's all evaluate means. So don't freak out when you see evaluate. You're not actually going through a big evaluation. It's literally just solve it. Okay, so number 1, here we go. This is a one-step expression, 16 plus b, if b equals 25. So now they tell you what the variable equals. So they tell us it's 25, all right? So the first step you have to do here is replace b with 25. So you just rewrite it like we did the other day, 16 and your addition, and then we replace b with 25. So 25 now. So now we have 16 plus 25. So what do? Just add it. So what's 16 plus 25? 41. Okay. So in that case, we only had one variable. You only have to replace one. They tell you with what it is, and then you just write it out and solve it. Okay. So one step, we did addition. Just one operation there. Okay. Number 2, x minus y. If x equals 64 and y equals 27. So what do we have to do first? What's our first step here? Isabella? Replace the variables. Okay. So the first one is x. What's x equal? So we replace x with 64. Okay. Now you don't change anything with the subtraction. That stays the same. You just copy it down. Okay. Just rewrite it. Now we replace y with what? 27. So now what operation do we have?
64.
No. What operation?
Subtraction.
Subtraction. Okay, so all we're doing is subtracting. So now we're doing
62 minus 27.
64 minus 27.
Okay.
So 64 minus 27 is what?
37.
37. There you go. Okay. Now this is the one that might trip you up a little bit. Okay. When you have this expression, 6x, okay, that is multiplication. You have to remember that. Because when you go to replace this variable with the number they give you, okay, do not write it like this. It is not 6.5. Okay, it just doesn't become formed together, and it's not a number together now. It doesn't form 6.5. It's 6 times 1.5. Okay, so you can either use the dot, and in this case, I prefer parentheses. It's a lot cleaner. Okay, especially when we start getting into equations. What I mean by parentheses is you write it like that. Okay, parentheses still mean multiplication. But like I said, whatever is easiest for you to remember, that means multiplication. You just have to remember that. Because you can't form a new number. You can't just put them together. All right? You have to do multiplication. So now we go to multiply. What's 6 times 1.5? Can we just up and do that?
No.
No. What do we have to do this 6? Put it over 1 in a fraction. Remember, 1 has to be your denominator. So let me rewrite this. So we get 6 over 1. Now we just multiply. What's 6 times 1? 6. What's 1 times 2? 2. Okay, are we done? No. So we get divide. What's 6 divided by 2? 3. 3 is your answer. Okay, so the one thing you have to remember with that is make sure that you just don't make it 6.5 or whatever the numbers are. So if you had like this, 3x and x equaled 64. This doesn't become 364. Okay, you have to multiply it. That's the one rule you have to remember here. Because I've seen people in the past get thrown off and they just start writing this number, and it's not right. So let's jump over to page 453. We're going to do a couple more of these. All right, number 1, m plus 10. M plus 10. Okay, hold on, you're jumping the gun here. The expressions say evaluate each expression if m equals 2, n equals 16, and p equals 1/3. So what does m equal? 2. So we replace it. So it's now 2 plus 10. So it's 12. Okay. So all your first step should be is replacing the variable or variables if there's more than one. So number 2, n divided by 4. So we have to replace n with 16. So 16 divided by 4. Now we just work it out and you get 4. All right, number 3 now. So now we have m plus n. So we have to replace both of them. So what is m? 2. We keep the addition. And then 16. And now we add 18. Okay, does everyone see how we're getting those? Guys, they give you what the letters are. You just have to replace them and then solve it. Okay, one more. Number 5, 3p. Okay, so we got to replace p. What's p equal? 1/3. Now remember, okay, it's not just written like this. It's not 3 1/3. It's multiplication. But like I said, you can write it with the dot. You can write it with the parentheses. You can use the old symbol if you want to. It's whatever makes you remember this is multiplication. So can we just up and multiply this? No. What do we have to do? We have to change 3 into fractional form. So it's going to be 3 over 1 times 1 over 3. Now, remember, you can simplify before you multiply if you want. It's totally up to you. Now, remember to do that, you got to look diagonally. So can we do anything with 1 and 1? What about 3 and 3?
No. Yes.
What can you divide out? Well, no, we don't. 3. Both of them are divisible by 3. So this becomes 1. That becomes 1. What's 1 times 1?
1.
What's 1 times 1?
1.
So our answer is 1. Okay, so let's go back. You guys try to do A, B, C, and D down at the bottom of page 450. So they give you what the variables equal. You just have to write them out and solve it. So take your time. I'll give you plenty of time, so go ahead and get started. All right, so letter A, who can walk us through this one? Emily. So what do we got to do first?
You gotta switch the A to 6.
Okay, so we replace A with what they give us is 6. So 6 plus 8. And now what do we do?
You add 6 plus 8, and that equals 14.
14. Any questions on that one? All right, letter B, A minus B. Steven, what we got to do?
Gotta switch A and B.
Okay, so what's A?
6.
Okay. What do we do with the subtraction sign?
Keep it.
Keep it. And then letter B?
4.
4. And now what do we do?
You subtract 6 times minus 4.
Okay.
It would be 2.
2. There you go. And letter C, so that's A times B. What do we have to do here? Fred?
You got times 6 and 4.
Okay, so we replace A and B with 6. A's 6, B's 4. So then we multiply and get what?
24.
24. And letter D. Who can walk us through that one? Isabella. Okay, so we replace C with 1/3. So it's going to be 9 times 1/3. Okay, what do we got to do now? Okay, we got to turn it into a fraction. So it becomes 9 over 1 times 1 over 3. And we get what? Okay, so she went ahead and simplified before she multiplied. Okay, so what did you divide out of both of these two? 3. So 9 divided by 3, 3. 3 divided by 3 is 1. So then you multiply it out and you get what? 3. And there's your answer. Okay, any questions on those 4? All right, so those are one-step expressions. Now, the next side of this is we're going to walk into evaluate multi-step expressions. So that means there's just going to be more than one operation. So you're going to have multiplication and addition, or multiplication and subtraction, okay? That's normally what you get, all right? It's usually multiplication and something else. So like this one, number 4, it says 5t plus 4. So before we even do anything, what operations do you see there? What's one of them, Isabella? Addition, that's one of them. What's the other one? Layla? Multiplication. Okay, so we have to do both of those. Now, but when you get into the expression, you have to follow order of operations, just like we did the other day. All right, so your first step always is to replace the variable with what they give you. So we have 5t plus 4. What's t equal? 3. So we replace t first. So I do 5. Like I said, I like using parentheses. It keeps things clean. Okay, it doesn't get sloppy. It looks all right. Still know that's multiplication. It's easy to go. Okay, now this is where you have to follow order of operations. Okay, so we have multiplication and addition. Which one do we do first? Multiplication. Okay, so we do 5 times 3, 15. Plus 4. Now we just finish it out. What's 15 plus 4? 19. Okay? So that's all you got to do with that one. I'm going to skip number 5 now and go down to number 6. We'll come back to number 5. So number 6. All right, we have 10a plus 7. So what operations do you see in the very beginning? What operations do we have? Isabella, what's one of them? Addition. What's the other one? Emily? Multiplication. So we got both of those again. Okay, so first thing I got to do is we have to replace the variable with what they give us. Well, a equals 1/5, so we replace a with 1/5. So now we have multiplication, and then we have the addition. Which one do we do first? The multiplication. It's just like order of operations, so you multiply first. So this is 10 times 1/5. We can't do that yet because we got to do what? Change 10 into a fraction. So what's 10 going to look like as a fraction? 10 over 1 times 1 over 5. Okay, so we just multiply this out now. What do we get? You can simplify before you multiply. So what can we take out of both of these? 5. So this is 2. That's 1. So then what's our answer going to be? 2. So now we have 2 plus 7, which is 9. All right, now this one I wanted to show you last because this is where it gets kind of tricky. Okay, so you have 4x squared. Okay, now this x is the one that has the exponent. The 4 has nothing to do with the exponent. So when you replace the x with the number, that exponent goes with that number. So basically, you can rewrite it as 4 times, now we replace it, that's 1/8 squared. Okay, so you see that the exponent has nothing to do with that 4. So per order of operations, you have to do the exponent first. So basically that just means 1/8 times 1/8. Okay, so it's
1 over 64.
exactly. So we have 1/8 times 1/8. So now all you have is 4 times 1 over 64. So now we just multiply it out. What do we have to do with the fraction?
Change it to where it's 4 over 1.
So now it's 4 over 1 times 1 over 64. Okay, let me just finish this out. So multiply it out, you get what?
4 over 64.
4 over 64. Can you simplify that?
No. Yes.
4 goes into 64 16 times. 1/16. All right, let's jump over back to page 453 again. We'll do a few more of those. So those are two-step, okay, multi-step expressions. So they have more than one operation and more than one variable sometimes. It just depends. So number 4, 6m minus 1. So your first step always is to replace the variable. So we have 6. What's m equal? 2 minus 1. So now what operations do we have? What operations do we have? Layla? What's one of them? Okay, subtraction. What's the other one, Emily? Multiplication. So 6 times 2, because we got to do that first, is what? 12. And then we just copy down the subtraction. Now we do 12 minus 1. 11 it is. Okay? Now, number 8. So that's just like what we just did. Okay, so we have 9p squared. So every time, your first step is to replace that variable. What's p equal? 1/3. So we do 9 times, and I like to do this in parentheses, 1/3 squared, because that exponent goes with that fraction, because that's what you replaced it with. So that means 1/3 squared is what? 1/9, because that's 1/3 times 1/3. Well, 1 times 1 is what? 1. And 3 times 3 is what? 9. So you have 9 times 1 over 9. Okay, we can't do that yet because we have to do what? Turn the whole number into a fraction. So that's going to be 9 over 1 times 1 over 9. So basically, what's 9 times 1? What's 1 times 9? So you have 9 over 9, which is 1. Okay, that's all you got to do for these, guys. Replace it and then just add, subtract, multiply, or divide. Like I said, most of the time in these chapters, all we're doing now is just adding, subtracting, multiplying, dividing. Nothing crazy. So let's go back, page 451, and I want you guys to do EFG. EFG. So take your time, write them out. So on these, okay, with letter E, F, and G, we said up here we had D equals 12, E is 1/3. So letter E, okay, we have 2D minus 5. So what's our first step here? Who can walk us through this? Isabella? What's it called? The variable. You have it. Okay, so we replace the variable with what? 12. So 2 times 12 minus 5. Now, this does not have to look the exact same as mine, okay? You did not have to use parentheses. I just like them because that's what I just always have used, okay? So what do we have to do first? You got to multiply. So multiply it out, you get what? 24. 24. Then we just copy down minus 5, and we get what? 19. Okay? And letter F. So we have 50 minus 3D Okay, what's our first step here, Layla? The variable. Okay, so what we got to replace it with? 12. So 50 minus 3 times 12. Okay, so we got to do what first now? Multiplication. So we just copy down the 50 in the subtraction sign. What's 3 times 12? 36. Stephen, how about you let her answer? Thank you. So 50 minus 36. So 50 minus 36. I think we need to look at that one real quick. So borrow, we get 4. What's 10 minus 6? 4. And 4 minus 3? 1. 14. Okay. Now, letter G. Okay, it's at 9e squared. So we got to replace, so 9 times, then we replace the e with 1/3. Just turn it off. Okay, so what do we got to do now? Isabella? Oh. You got to do the exponent because of order of operations. So we do the exponent first. So that'd be 1/3 times 1/3, which is 1/9. So 9 times 1/9. And now what do we do? So we got to change this to a fraction. So it's going to be 9 over 1. And then we multiply it out and you get what? 1. So 19, 14, 1. Any questions on those? Guys, I give you what the variable equals. Just replace it, solve it out. That's just, so basically, after you replace the variable, it's just like what we did the other day with numerical expressions. Just all numbers now, and you're just solving them. Okay, on the next page, you're going to see a real world link. Okay, so down here on number 7. Okay, so number 7 here. So it says the amount of money that remains from a $20 bill after Melina buys 4 party favors for P amount of dollars each. So right here, P means dollars for the party favors. We don't know how much she spent on each one, but we know she bought them. She bought 4 of them. Okay, they want to know how much money we have left over from a $20 bill. All right. So they give you the expression, and then they tell you what the party favors cost. But they don't come out and say that P equals 3. We have to infer from here that P is the cost for party favors, which is $3 a piece. So you replace P with what? 3. So then you just solve it. So 20 minus 4 times those $3 per one, and now we just solve this out. So what do we got to do first? The multiplication, the 4 times 3. So 20 minus 12, and now we do what? And then we just subtract, which get what? $8. So that's all that's left out of that $20 bill after she bought those party favors. So that's the only difference you're going to see on a real world example. Okay, they're just not going to come out and say P equals 3 like the other ones did. Okay, you have to read through it and infer through the description what it is. Okay, any questions on those? All right, your homework is on IXL, 6th grade math, section Y, number 4, and Y, number 5. Okay, take your time, write them out, read the directions. If you have any questions, come up and see me or call me over.